Hey guys, all right. So lesson 4.7, right? I'm going to talk about quadratics, what they are, what do they mean, what do we do with them, right? But first, I want to start with, and you'll see this on your screen, what is multiplication really? So what is multiplication really? Well, multiplication really is called repeated, whoops, that's not how you spell repeated, repeated addition, right? So we have something like 2 times 4, which equals 8, is really 2 plus 2 plus 2 plus 2, right? This is saying 2 4 times, which is why we get 2 times 4, okay? Next, and this is on your screen, you should see what do exponents really represent. So, I have something like 2 to the 4th. What does that represent? Well, it's repeated multiplication. All right? So 2 to the 4th becomes 2 times 2 times 2 times 2. Do that. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay? Just like if I were to have, let's say, x plus x plus x is really 3x. I'll have x times x times x equals x to the 3rd. Okay? So these are our basic rules. So here's 2 examples. We have 2 to the 3rd and negative 3 squared. 2 to the 3rd, we said, is 2 times 2 times 2, and that's going to equal 8. Negative 3 squared is negative 3 times negative 3, and that's going to be 9. Now let's say I had negative 3 to the 3rd, that's going to be negative 27, right? Because we have a negative times a negative is a positive, and then times another negative gives me a negative. So, what is a quadratic? Well, a quadratic is an equation where the highest power is 2, right? So this is something like x to the 2, f of x, right? Algebra 2 pants time. F of x is equal to x squared plus, we'll say, 3x minus 9. Something like that. All right? And this is what's known as a quadratic. In a quadratic, the standard form is going to look like f of x is equal to, I want you to pause and see if you can figure this out for yourself. So hopefully you paused, you took a guess, and if you're lucky, maybe you guessed something like ax squared plus bx plus c. This is our standard form, right? Because when we're doing something in standard form, we want all variables. This way, when I have a real problem, I can plug in the pieces that I don't know and solve. So my a here would be 1, my b would be 3, and my c would be negative 9. Right? So hopefully you're following along with your notes, and you have a quadratic equation creates and it's going to be U-shaped curve. So we're done with rulers, and now we're getting into curves, right? And this U-shaped curve is what's known as a parabola. All right? Parabola. It's not parabola, it's called a parabola. Okay, so here is my first example. And just by looking at it, we have x squared plus 2x minus 5. So taking a guess, what do you think that looks like? I want you to draw that now, and then while you're at it, and I forgot to put the graph, go ahead and take a guess at what negative x squared plus 3x plus 7 is going to look like. So hopefully you took a guess, and hopefully you drew something that's looking kind of like this, right? With this point being -5. And over here, we have something looking like that. Okay? So, going back to our standard form, I'll write it here, and I'll try to keep it up for the rest of the video. What do we notice when our a, which is our coefficient of x squared, is positive? So hopefully you have a U shape, and that it opens up, right? Positive a goes to positive infinity. So that's the easiest way to remember it. Over here, right, we have a negative a. So what should we notice? It's going to be an upside down U shape, and it's going to open down. Okay? Negative a opens to negative infinity. So now we have a vertical line that divides our parabola into two equal parts. So we can see, if I were to draw a line right down here and fold that on that line, and I can do the same here, I have two equal parts. My drawing might not be the best, but you should see the Desmos graph on your notes, and that will kind of show you what it looks like, right? So what do we call this line? Well, it's called the axis of symmetry. Okay? This dotted line is called the axis of symmetry. And it has a formula. And its formula is going to be negative b over 2a. Okay? And we get our b and our a from here. And that's how we can find our axis of symmetry. So for this first one, negative b is going to be -2 over 2 times a, which is 1. I get -2 over 2. And I drew that wrong. My graph should have looked something like this. Right? So we'll get rid of that. Get rid of this wrong axis of symmetry. Get rid of all this nonsense. So that's at -5. And that's going to be at -1. Right? And it's x equals -1. So my axis of symmetry is an equation. X equals some constant. And that makes sense, right? Because we have a vertical line. What's the equation of a vertical line? X equals some constant. So for final answers, if you put -1, it's wrong. It has to be x equals that number. Over here, we can do the same. Negative b becomes -3 over 2a, -2. That's going to equal 3 over 2, which equals 1.5. So I can say that right here is 1.5. Okay? So the turning point of my parabola, right? My bottom right here and my top right here. It has a name. Just like it did for absolute value, it has the same name, and it's called the vertex. Okay? And our vertex is where our graph shifts from being positive to negative and negative to positive. And we're able to find that vertex, right? How do we do it? Well, what do we notice? We notice that our axis of symmetry runs right through our vertex. So how do we find our vertex for absolute value? We found out what our x value was by setting the absolute value equal to 0, and then plugged it in. Same thing. We find our axis of symmetry to give us our x value, and then we plug that in. So, for this one, we have negative 1 squared plus 2 times negative 1 minus 5, which is going to give me 1 minus 2 minus 5, which is negative 6. Right? So my vertex is at negative 1, negative 6. 1, 2, 3, 4, 5, 6. And that's right here. So this is my vertex, and it is at negative 1, negative 6. I can plug it in over here as well. I get negative 3 over 2 squared. Right? And write it like that. Plus 3 times negative, or positive 3 over 2. Plus 7. So first we do our squaring. 3 over 2 squared becomes 9 over 4. And we said it was negative. Plus, multiply straight across, 9 over 2 plus 7. This becomes negative 9 over 4 plus 18 over 4 plus 28 over 4. Go straight across, that becomes 9. 9 plus 28 is going to be 37 over 4, which is equal to 9 1/4. So 8, 9. Right? So this point then is my vertex, and its coordinates are 3 over 2, comma, 37 over 4. And that's my ordered pair for that. So, when our vertex is at our lowest point of the graph, right? So we can see that that's our lowest point. It has a special name. And that name makes sense. It's going to be called the minimum. And a trick to remember, just like we know for positive A, it opens up. For a positive A, I'm going to add this here, vertex equals minimum. So conversely, over here, where my vertex is my highest point, that's going to be called the maximum. And again, I'll put this in the chart. Negative, that shape opens down, vertex equals maximum. Alright, so you should be looking at the first example, which is f of x is equal to 4x squared. So, we're going to go in order of what we can determine, right? So right away, I can determine, is that a maximum or a minimum? How do I determine that? I look at my A. A is positive, so I go here. So it's going to open up, it's going to be U-shaped, and my vertex is going to be a minimum. And circle minimum. Now I need to find my axis of symmetry. So I ask myself, what's A equal? What's B equal? A, we said was 4. And B, well, our B is our coefficient of x. And it's not there. So what should it be? 0. So we have 0 over 8, which equals 0. So my axis of symmetry is x equals 0. And again, to find the vertex, I plug that point in. So I plug in 0. 0 squared, 0. 0 times 4 is 0. So I know I start here at 0, 0, and I open up. So my rough graph should look something like that. All right. You now have number 2 on the board. I want you to go ahead, give that one a try on your own, and tell me what you get. Alrighty, hopefully you gave that a shot. You ended up with a maximum. Vertical, or our axis of symmetry is x equals 3. Our vertex is at 3, 9, and we have something like this. And I forgot to label my vertex of 3, 9. Right? And then we said it's downward shaped, it opens down, so it should look like that. So hopefully you got that. Let's move on to the next example, number 3. So for number 3, we have 3x is equal to negative 2x squared plus 7. Okay, so go through the steps. Is it a maximum or minimum? Well, what is my a? My a is negative 2, so it's going to be a maximum. What is my axis of symmetry? So a is equal to negative 2, b is equal to, well, there is no x term, so it's 0. So I have 0 divided by negative 4, which is 0. So my axis of symmetry is going to be x equals 0. I then plug that in, right? So I get 0 squared is 0 times negative 2, 0 plus 7. So my vertex is going to be at 0, 7. 1, 2, 3, 4, 5, 6, 7, 8. I only need to go up to 7. There's my vertex, and we said it's a max, so it opens down. So it's going to look something like that. Finally, give the last one a shot. Find the maximum, minimum, axis of symmetry, vertex, and give it a rough graph and see what you get. Alrighty, again, hopefully you gave it a shot. You ended up with a minimum, axis of symmetry being at 4. Plug in 4, you get negative 7, and a rough graph that looks like this. So hopefully this helps. This is very important, and this is only part 1 of our lesson. We're going to move on to part 2, where we go from a rough graph like this to the one you're seeing in Desmos. It should be there for the answer. We're going to be able to graph that by hand. So hopefully this helps. Move on to the next lesson.